Hello everybody. I welcome you all to NK's geology class. Today I will discuss about some of the important terms in ore geology. These are ore, gangue and tenor. So let us discuss what is ore. Ore is simply defined as the natural occurring substance from which one or more metals can be extracted at profit or it can be extracted economically. And it does not include the industrial minerals, non-metals, gemstones, fossil fuel and rocks. But according to the Institution of Mining and Metallurgy, United Kingdom, the definition of ore has been changed. It includes all solid natural occurring mineral aggregates of economic interest from which one or more valuable constituents can be recovered by treatment. So it includes all natural occurring mineral aggregates which are of economic interest. They can be called as ore. But previously the term was simply used for the metallic minerals from which metals can be extracted economically. So according to the present definition, it includes all solid natural occurring substances which are of economic interest and can be obtained from nature by simple treatments. And these ores include the following types of minerals or deposits. These are metallic deposits, noble metals, industrial minerals, rocks, aggregate materials, gravel sand, gemstones, polymetallic nodules, mineral fuel, natural water, because all these materials are of economic interest. That's why they have all been brought under the very term ore. Thus, it can be said that all ores are minerals or they are aggregates, but not the reverse. All minerals cannot be ores because the term economy is there. It must be economically important, then the mineral aggregates can be called as ores. So we have the above 10 types of ores: metallic deposits, noble metals, industrial minerals, rocks, aggregate materials, gravel, sand, gemstones, polymetallic nodules, the mineral fuel, natural water. So all are grouped under ores. Let us take the example of some of the ore deposits such as lead and PB deposits of Rajasthan, that is at Jawar, Rampura Gucharia and Rajpura Daribaria. Similarly, copper deposit we have Khetri copper, Rajasthan, Singhbhum copper, Bihar, Malajkhand copper, Madhya Pradesh. Iron ore deposits: Kudremukh iron ore, Karnataka, Doitari iron ore of Orissa, Nuamundi iron ore of Odisha. Similarly, we have the chromite ore deposits at Sukinda of Jajpur district, Odisha, Nausai, Keonjhar district of Odisha. Gold deposit, Kolar gold belt deposits of Karnataka. Limestones, Jaisalmer, Rajasthan. In Odisha, we have Biramitrapur, Lanjibana in Sundargarh district. And rock phosphates, Jhamarkotra, Udaipur of Rajasthan. Marbala, Makrana marble, which are there at Nagaur district of Rajasthan. This marble has been used in many monuments, including that of Taj Mahal. In magnesite found at Salem of Tamil Nadu. So these are some of the metallic and non-metallic deposits which are considered as ores. And there is another ore, another term, that is proto-ore, or we can say it is a primary ore, or you can say it is a original ore. Original natural occurring substance. Generally, it is of uneconomic value, but because of operation of the different processes such as weathering, oxidation, leaching, chemical, physical alteration, these uneconomic ores, which are the original ores, they may become ores. So, original non-economic ores or minerals are generally described as proto-ores. And it is found to be changed subsequently by other processes, as a result of which the concentration of metals are found to be increased and they become ores. So, original ore is, it may be economic or may not be economic. So, original ore is generally called as proto-ore. It is an altered rock or a primary mineral deposit, or it is a primary parent rock that shows an uneconomic concentration of minerals or metals. Original, first formed ore, that is proto-ore. It may be further enriched by natural process to form ore. So, proto-ores, they represent the original ore and they generally are of low grade, and they represent the residual deposits which are produced. They may represent residual deposits which are produced by weathering, oxidation, leaching and physical chemical alteration processes. And by these processes their quality may be upgraded. So proto-ores can be turned into ore deposits by these processes or by advanced technology or because of rise in price of the minerals. So, if the uneconomic ores can be economically important, in that case they become ore. So, proto-ores can be ores by the different processes or by advanced technology or by increase in price of the minerals. Example. For example, weathering of feldspathy granites, khondalites produce kaolin, bauxite, because we know khondalites are the source rock from which we can get bauxite. For example, in Orissa, the khondalites, they represent the major rock types of Eastern Hard group of rocks. And these khondalites, they have been altered and they provide the bauxites, which is a residual ore mineral of aluminium. Similarly, kaolin, it is a clay mineral. So, the granites and chondrites, they form the protor, from which we, by the operation of residual concentration process, the kaolin and bauxites, they have been produced. So we can say chondrites, feldspathic granites are the original rock, and they have given rise to economic bauxite and kaolin. Similarly, weathering of mafic and ultramafic rocks, which are the protors, such as basalts and pyrites, they produce laterite, iron ore, nickel. We have found nickel deposits in Sukinda belt of Odisha. Sukinda area is known for the chromite deposits associated with the ultramafics. And these ultramafic rocks, they have been altered. They have been chemically leached, and we find the formation of nickel. We find the concentration of nickel. So, the original mafic ultramafic rocks, they are found to be enriched by the process of, by the operation of the residual concentration process, by which they have been enriched to give rise to nickel. They have produced iron ore, they have produced laterite, and originally these rocks, they are the source of the chromite ore, because the ultramafics, they generally are found to be rich with chromite. Similarly, we see that martite is called the protor of hematite, and it is the pseudomorph after magnetite. So the mineral martite is a hematite ore, and it has the structure of magnetite, that is cubic form, octahedron. So the form is octahedron, but composition is hematite, and it has been produced from magnetite due to oxidation to produce hematite, and it is found to be associated with banded iron formation of Precambrian age. So martite is called the protor of hematite, or we can say magnetite is the protor, and it has been converted into hematite through oxidation. But the very form of magnetite, which is cubic in its formation, or which has cubic form, that cubic form is being retained in martite, but composition changes from magnetite to hematite. So by oxidation process, magnetite has been converted to hematite, and this hematite or martite is called the protor of hematite. So protor may or may not be economic, but because of the changes, because of the operation of different processes, the uneconomic ores may become economic. But here magnetite is economic, but it has been converted into hematite through oxidation, and it takes the its original structure is being retained but composition has been changed. That's why it forms a pseudomorph. And this pseudomorph is called the martite, which is a hematite. And this martite is therefore it is called as a protor of hematite. So protor represents the original ore. It may or may not be economic, but by operation of other processes such as residual concentration, oxidation, supergene enrichment, these are the processes by virtue of which the original uneconomic ores may be converted into economic ores. Similarly, siderites are the proto-ores for hematite, limonite. Rhodochrosite is proto-ores for manganese minerals such as pyrolusite. It is so these are not economic. Siderites, rhodochrosites, they are not economic minerals, but they become economic by later processes. So they form the proto-ores. So proto-ores represent the original ores. Mostly they are uneconomic. Later they become economic. Either by advanced process of technology they can be made economic, or by rise in price, or by operation of different processes such as oxidation, supergene enrichment, weathering, leaching. So they become, by these processes, these original ores become economic. So this is all about proto. Now let us discuss what is gangue. Generally, ore minerals are found to be associated with some other minerals, as a result of which the quality of the ore is found to be degraded. And these materials which degrade the quality of the ore need to be removed, so that the quality of the ore can be upgraded. These useless materials which are associated with the ores are called as gangue minerals. So ore minerals are not found to be 100% pure. They are found to be associated with rock forming minerals during their process of formation, during their stage of mineralization. These associated minerals or rocks which are not of significant value or of commercial value are called as gangue minerals, and they have to be removed in order to upgrade the quality of the ore. The common gangue minerals which are associated with the ores are quartz, dolomite, garnet, gypsum, mica, pyrite, pyrrhotite, barite. So these are some of the metallic and non-metallic minerals that come in association with the ores, and they need to be removed in order to make the ore, in order to make the grade of the ore high. So these minerals are separated from ores by adapting beneficiation processes at the mine sites, so that the grade of the ore can be enriched. What are the beneficiation processes? Beneficiation process may include gravity separation process, gravity separation, magnetic separation, electrostatic separation, then it may be by agglomeration, it may be by froth flotation. So these are some of the methods which are being adopted in order to upgrade the quality of the ore before they are being fed to the blast furnaces for metal extraction. So these processes are adopted in order to separate the gangue minerals from the ores, as a result of which the quality of the ore is found to be upgraded. So these are the beneficence processes by which the gangues can be separated from the ores. Also, ores are found to be associated with certain deleterious minerals which are separated to make the quality of the ore better. For example, arsenic is associated with nickel and copper. Mercury is associated with zinc. Phosphorus is associated with iron. Calcite is associated with uranium. So these minerals are separated in order to upgrade the quality of these deposits. Iron, nickel, copper, uranium. So the deleterious components associated with the ores are also found to be they are also removed in order to make the ore or the mineral directly usable in the extraction process. So gangues are the useless material which usually come in association with the ores, and they must be removed in order to make the ore suitable for extraction purpose. Now let us discuss what is tenor. It is defined as the lowest percentage of admissible metal content in an ore. Lowest admissible percentage of metal content in an ore, so that the extraction can be possible economically. And this tenor value depends upon the following factors. Following. What are they? The price of the metal. Higher the price of the metal, lower is the tenor value. For example, all precious metals, gold, platinum, which are very costly, and their tenor is determined in grams per ton. That tenor is very low. Similarly, lower the price, higher is the tenor value, as is found in case of iron, aluminium. More than 40% of iron, aluminium, generally they become the tenor value. So, the quality, the price of the metal determines the tenor percentage, which is the minimum metallic percentage on the basis of which the metal can be extracted economically from the mineral. So beside this cost, the other factor is the availability and quality of the metallic deposit. If a deposit is plentifully available, in that case the grade of the deposit is taken into account. Plentifully available, for example iron. Iron in India is plentifully available. In that case we do not take into account the low grade ores. We take into account the high grade ores for metal extraction, because we have the plenty of material. We have plenty of resources. If the grades are high, then tenor value becomes the high. For example, in India, there are huge deposits of iron. So low grade iron ores are not used for metal extraction in Indian context. Hence, the tenor for iron in India is high, that is more than 50%. When the high grade ores will be exhausted, the tenor value will be lowered, keeping in view the cost of production, so that economy is ensured. And another factor is the industrial setup of a country. The countries which are technologically advanced can utilize low grade ores for metal extraction, and hence tenor value for those countries will be lower. For example, Japan. Japan is a country which is not containing economic mineral deposits, and it depends upon other countries for supply of economic minerals, and by using their own technology, advanced technology, they make the low grade ores directly usable at profit. So Japan, the grade of iron ore is very low, or the tenor is low, and Japan purchases the iron ores from India and utilizes the same low grade iron ores for their metal extraction. But in our country, the technology is not fully developed to utilize the low grade ores for metal extraction. Because we have plenty of resources, we do not give importance for the use of low grade ores, we use the high grade ores which are available to us. Thus, tenor value varies from a country to country. The technologically advanced countries have low tenor value compared to the countries lacking advanced technological know-how for metal extraction. So, the cost is a factor, then availability is a factor, then technology is a factor which controls the tenor value of different metals or minerals, so that economy is ensured and the percentage of metal is decided. For example, here the tenor values have been given. Platinum, it is about 0.1 ounce per ton, gold 0.15 ounce per ton or 4 to 6 gram per ton. This is generally the tenor values. Silver 10 ounce per ton or 280 grams per ton. Like this, we have the tenor values for copper, lead, zinc, nickel, tin, aluminium, chromium, iron. For example, iron 30 to 50% iron, manganese 40 to 50% manganese. So these are the tenor values. And tenor values are subject to change from country to country depending upon their technological development, depending upon their resources, supply position, depending upon the cost. Now let us discuss what is grade. Grade of ore. It is a qualitative term used for the ore deposits. It is defined as the percentage of valuable mineral or metal in an ore. It indicates how rich the ore is and is a key factor in deciding whether a deposit can be mined economically or not. The units of grade. What are the units? The grade of ore is expressed as the percentage of metals like iron, manganese, chromium, aluminum, copper, and it is expressed in terms of grams per ton for precious metals like gold, platinum, silver. It may be expressed as kg per ton in case of rare earth minerals, heavy sand in beaches. It is expressed in terms of ppm, parts per million, for trace elements. So these are the units. And types of grade based on metallurgy, or that is extraction of metal from ore. We have high grade ore, medium grade ore, low grade ore. For example, in case of iron, high grade is generally more than 62% iron. In medium, 58 to 62%. Low grade less than 58%. So high grade ores are high in metal content and low grade ores are low in metal content. Then we have the run of mine grade. In running condition, what is the grade that is recovered from the mines? It is the grade of the ore obtained during the mining process. Cut-off grade. It is the minimum grade at which the ore can be mined profitably, below which it will not be economic. So, it is the boundary between economic and uneconomic value. And below this grade, generally the ores are not used for metal extraction because economically affected. So, the grade of the ore below the cut-off grade is considered as a waste and above it is considered as the ore. Based on purpose for which the ore is used, we have the different types of grades, such as the chemical grade in chemical industries, manganese in preparation of potassium permanganate, copper in blue vitriol, copper as disinfectant. So based on purpose, the grades are decided. In all above cases, pure metals are used or high grade ores are being used. Similarly, limestones used in chemical purposes should be pure up to 97 to 98%. Salts of halite should be pure up to 99%. So when you talk about the purpose, accordingly the quality of the mineral are considered so that the purpose for which it is being used, that is not affected in any manner. Similarly, battery grade, manganese, lithium, they are used in battery, and the graphites are used in also graphite is used in battery. So manganese, lithium, graphite, they are used in battery and they should be of high grade. Manganese dioxide should contain more than 80% manganese. Lithium carbonate should have 99% pure quality. Similar, graphite should be pure. There are similarly other grades such as refractory grade. The materials which are used as refractory materials in blast furnaces, they should have the ability to withstand high temperature pressure conditions without any deformation. So the refractory grade, the minerals or rocks which are used as lining in the furnaces, kiln walls, they should have that property of bearing the fluctuation of high temperature pressure conditions, high temperature conditions in the blast furnaces. For it, we have the different specifications. Bauxite with Al2O3 more than 80%, 85% is being used. Magnesite with MgO percentage more than 90 to 95% is being used. Fire clay with Al2O3 more than 30 to 45% is being used. It should be low in iron. So these are the purposes for which we use the different grades of the minerals. Similarly, we have the ceramic grade. Quartz should be 99% pure. Feldspars low in Fe are used. Kaolin low in TiO2. Titanium oxide is being used. We have the pharmaceutical grade. The minerals highly pure are used in preparation of medicines. For example, calcium carbonate used with more than 99.5% purity is being used in the medicines talc should be asbestos free. Barium sulfate should be very pure so that they can be used in pharmaceutical industry. So these are some of the purposes for which the materials are being used. So we have a metallurgical grade, we have the run-of mine grade, we have the different grades based upon the purpose for which the metals or minerals are being used, chemical grade, battery grade, refractory grade, ceramic grade, pharmaceutical grade or medicinal grade. So these are the purposes for which metals are being used or minerals are being used. So this is all about the grade. So I discussed how these terms are being used in ore geology, what is ore, what is protor, what is tenor, what is grade, and how the term ore is being applied to 10 types of minerals. And I think I have tried my best to give the required information about these three terms: ore, tenor, and grade. Thank you all for your patient hearing to this topic.